Hello, hello. Welcome here, everyone. Hope you all are having a good morning or afternoon or evening, wherever you might be today. I myself am tuned in from Delta, BC, just outside of Vancouver. We'd love to see where everyone else is joining from. We've got a good group online now, so feel free to chat that in. What about the rest of our panel? Anyone else close by Vancouver, BC on our webinar presenting panel today?
Yeah, I'm actually located downtown Vancouver. I'm Donald. Nice to meet everybody.
Welcome here, Donald. And Ali, what about you? Where are you located today?
I am located in the East GTA, so the Greater Toronto area.
Very cool.
I'm actually not too far from Ali. I'm about 20 minutes more east in Ontario as well.
Okay. Very cool. Okay, let's take a look at the chat here and see where everyone is joining us from. Lots of input today. Awesome. Well, thank you so much for joining today, everyone. We will get started in just a few moments here. It looks like people are starting to roll in now that we're at the top of the hour. All right, I will go ahead and kick us off here. We have a lot of great content to cover today. So welcome here, everyone, to From Pixels to Insights, getting started with imagery in FME. Today, I am joined by our lovely panel of 3 presenters, and I'll pass it over to Donald to introduce himself.
Hey guys, I'm Donald. I'm originally from Ireland, but have moved to Vancouver about 6 years ago. I'm with Safe Software about a year on the technical support specialist side with FME Form.
And Ali.
And my name's Ali. I'm also on the technical support specialist, same team as Donald and Kaylin. We answer your questions on the community. We take your support tickets, and you can see us doing webinars like this.
And hello, I'm Kaylin. I am also a technical support specialist on the FME Form side.
Awesome. And I want to shout out Dimitri on the back end. He was a great support in content development for this webinar. It's great to have his expertise. For any questions that you might have, please do get those into the questions panel as we go along here. You'll see it on the bottom right there. And that way we're able to reply directly to your questions. And we'll also have live Q&A at the end as well. Keep letting us know where you're tuning in from in the chat on the bottom right. You can also share your emoji reactions with us during the webinar. So use that react button and let us know how you're feeling throughout. And then we also have the help button on the bottom left. So if you have any audio or video issues, you can click that for 4 simple steps to take. You can also download the slides by clicking that button on the top right of the PDF. Okay, with that, I will pass things over to Donald for our agenda.
Yeah, thanks, Elizabeth. Good morning, all, and thank you for joining. To kick us off, I'm going to give us a quick run through of our agenda. So the introduction and imagery fundamentals, I'm going to be taking care of this part. And then I'll hand it off to new imagery resources, which Ali will go through. There's some great new transformers that we've created that we want to show off. Then we're going to hand it off to Kaylin for common imagery tasks in FME. And then we're going to hand it back over to me, who will finish off with advanced imagery. And finally, Ali will wrap it up with the conclusion. We have a next steps and resources section, and then we'll finally end with a Q&A, which we hope you all ask some questions. So without further ado, I'm going to kick us off with an introduction. So welcome to our webinar, Pixels to Insight, getting started with imagery in FME. To those that are new to FME, or this is your first exposure to FME, FME is the only all data, any AI integration platform. Today, we are going to dive into just one of these data types, imagery. We're going to discover how FME can transform your imagery into notable outcomes, streamlining your workflows, integrating data where it's needed. But what do we mean when we talk about imagery? Firstly, we need to distinguish between imagery, photos, and rasters. So a raster is the technical accurate term for referring to a data structure that organizes information in a grid of pixels. Imagery is a type of raster typically captured by sensors on satellites, planes, drones, or other platforms. Photos, I'm sure we're all familiar with photos. It's a more generic term, commonly used to describe images captured by cameras. Now, there's a huge array of data and models to work with. One of them is a DEM, or a digital elevation model, a specific type of raster where the grid cells store elevation values commonly used in geographic and topographic applications. FME works effortlessly with raster data. There are over 50 transformers dedicated entirely to raster processing, and they all start with the word raster. That means whether you're analyzing satellite imagery, transforming digital elevation models, aligning rasters, or extracting key information, there's a tool specifically designed to make your task faster and easier. But what are the benefits of imagery? Imagery processing unlocks the potential of visual data, transforming raw images into actionable insights for smarter decision making. For example, satellite imagery can be used for water management and urban development, while AI-driven tools can identify features like vegetation or infrastructure from drone images, enabling environmental monitoring or asset management. With imagery processing, the possibilities to streamline operations and uncover valuable insights are endless. But of course, there's going to be some common frustrations people face with imagery data, and these include the difficulty managing large volumes of imagery data efficiently. So for example, handling vast amounts of raster data, especially from satellite or aerial sources, can be daunting due to file size, formats, and the need for structured organization. There's complex processes. So preparing images to extract actionable information from raw imagery often requires multiple complex steps involving data transformation, analysis, and integration. And of course, there's limited resources for accurate image enhancement and analysis. So organizations may lack the tools or expertise needed to enhance imagery and drive meaningful data. But of course, there is a better way with FME. You shouldn't have to experience those problems. By leveraging FME's capabilities, organizations can manage and process large volumes of imagery efficiently, enhance and analyze imagery accurately, even with limited technical resources, and simplify complex workflows to extract actionable insights from raw raster data. I'll now move on to the imagery fundamentals. And in this, we're going to talk more about imagery terminology, how imagery is used, the different formats used in imagery, and finally, how imagery is represented in FME. So raster terminology. Here I'll cover some common terms used in the imagery world. So imagery, this is any type of photograph captured by electronic devices such as satellites, aircraft, cameras, and mobile phones. Imagery is comprised of pixels. Within FME, these are referred to as cells. This is the smallest unit of a raster image representing one or multiple values. The total number of cells will define an image resolution. The resolution is the real world size of a pixel. High resolution has more pixels, so it will be more detailed, while low resolution has fewer pixels. It will be less detailed. Some other important terms in the world of rasters include raster bands. So a raster dataset can contain a number of different layers known as bands. Another way of looking at this is to say each cell can consist of a number of values. And then we have a palette. A palette represents each of the pixels in a raster and lists each of the colors associated with each pixel. Types of rasters. There's two main types of rasters, numeric rasters and color rasters. Numeric rasters are typically represented a single band with continuous or discrete numeric values. These numbers can either represent smooth changes, like elevation or temperature, or categories, like land types. For example, 1 equals forest and 2 equals water. These rasters are typically used for analysis, modeling, and visualization in GIS and remote sensing. So for example, a digital elevation model would be a numeric raster. Color rasters. These rasters represent multiple bands combined for visual interpretation. RGB rasters combine 3 color layers, red, green, and blue, to create images we can see and interpret. These rasters are widely used for visualization, photogrammetry, and mapping. Examples of these would be aerial photography and satellite imagery. How is rasters used in the industry? Well, raster data is commonly used for understanding, engaging, and communicating information across platforms and communities. Here are some common uses. So in digital photography, it captures moments, landscapes, and events in digital form, often used for artistic, personal, or professional documentation. With web design, it enhances visual appeal, user experience, and communication on websites. Attachments. So these are supports communication by including visual information in emails, reports, or documents. Orthophotos, they provide geographically accurate images for mapping, planning, and analysis. And then historical archives. It preserves visual records of cultural, historical, and environmental significance. When working with rasters, there are many different formats that can be used. Here are some of the common types that people work with. A JPEG, this is often used in digital photography and casual image sharing. PNG, this is often used for web design for icons, logos, and graphics requiring transparency. And a GeoTIFF, often used in satellite imagery and digital elevation models. But FME can connect to much more. Just look at this image here. FME is capable of working with each one of these formats. Within FME, some common terms may be referred to slightly differently. A pixel is represented as a cell in FME. A channel would be represented as a band. A raster or image will be represented by a feature type, and resizing is known as resampling. As mentioned, an image is represented as a reader or writer feature type. Within FME, a reader is how our data is read into our workspace, and a writer is how we choose that data to be written out and represented. I'd like to now hand over the next part of our webinar to Ali, who will lead you through the new resources and transformers section. Thank you.
Yeah, thanks, Donald. So that was a great overview of an introduction to imagery, imagery fundamentals, benefits of imagery, and how we interpret it in FME and what we support. So now we're going to jump into new resources and transformers. So getting into this section, we've created new resources in Hub Transformers. So the new resources that we've released on the knowledge base is common imagery tasks. That's going to be shown a bit later on in this webinar. Also, there's an article dedicated towards it. Definitely check it out. Links will be provided in the chat for this. And then imagery basics, also a great introduction to imagery, and then it goes into a bit more advanced details. So if you're interested, definitely check that out. And then image compression as well, which is a really good read, and also has some practical examples there. And towards the bottom there, those 4 bullet points at the end, we're going to go through image watermarker, image identifier, image color adjuster, and then image haloers, which we'll get into detail in the coming sections. So for the image watermarker, how this works is you bring in an image that you would like to be your watermark. It can be a logo, it can be an icon, or pretty much anything of your choice. And then bringing in a base image as well, which it can be a photograph, scanned map, PDF, and then your watermark will be overlaid on top of that base image, which this transformer does and what we've built for you here. So if you look on the right there, this is its parameters. You can adjust the angle of your watermark, choose its opaqueness, and then the column and frequency you'd like that watermark to be within that base on that base image when it's overlaid, and then the scale factor that you'd like to set it. So jumping into the demo here. So we have a GeoTIFF of Cole Harbour in Vancouver, and then a PNG image of our FME logo there. So we'll run our workspace, and then once that's run, you will see that FME logo was overlaid on top of our GeoTIFF there, which is pretty cool. So the next one is image identifier. So this is another great transformer. It's designed for use with Olama. So we used Olama here, and it uses the Lava multimodal model. And quickly, Lava is basically an end-to-end trained large multimodal model that is designed to understand and generate content based on both visual inputs and textual instructions. Here we opted for textual instructions, as you can see on the right there. We have our Olama URL, which is the default, and of course, I'll say this during the middle of this. All information you can check out on the hub for more details about our transformers, and then our prompt, which is our textual instruction there. And this will be set in our next demo here, which is what does this image contain? And then intended for use with JPEG and PNG image formats, which is a limitation to Llama here. So getting into the demo. So here we have a image that we've grabbed from Unsplash, which is architecture here, an RGB image. And what we're going to do is run our workspace with the same parameters that you've seen in the previous slide, which is what does this image contain? So once this runs, it will output an attribute that's content, as you'll see in a moment here. And it gives it a paragraph description of what this image contains. So we'll open that here. And you can see there, this image shown a modern abstraction art piece with, yeah, so it gives an explanation of what that image contains, which is really, really cool. All right, so for our third transformer that we've developed is the image color adjuster. So the image color adjuster, it sits in adjusting your image's color. We have 5 options here. We have brighten, color correction, grayscale. You can invert your color, and gamma correction. And also I wanted to give the gamma correction here in this transformer is inspired by one of our colleagues, Dave, which he made the RGB gamma corrector. So shout out to him. And then also this is intended for use with JPEG and PNG image formats. So as you can see on the right there, that's its parameters, and you have those 5 options and 5 output ports. So jumping into the demo. So we have the same image from our other transformer demo, which is the image identifier, that same architecture there. And what we're going to do here is we're going to select this time grayscale. So we'll click OK, we'll run this workspace, and then with the magic of this transformer, it will be grayscale, which is really, really awesome. All right, so last but not least is the imagery haloer. So what this transformer does, it creates a halo around an image, and it's basically a gradual blend of the surrounding user selected color. So as you can see on the right there, you can select a halo color. We've chosen a blue here, but you have all those color options to choose from. And then the number of buffers and buffer size used as ground units. And then keep in mind your image that you're bringing in needs to be georeferenced for this transformer to work. And then as a result, it creates smooth effects and transitions from imagery to a background. So you can use this in your presentations, websites, or whatever you need there. And it's usually used for focusing on a particular area, so an area of interest, for example. So jumping into the demo. All right, so we have GeoTIFF, which is georeferenced. This is a image from a neighborhood from Austin, Texas. So we can zoom in here and you'll see details of that image. And then what we're going to do is bring in a polygon here, which is basically a clipped area of our GeoTIFF image over there. We've prepared that ahead of time, and we've clipped a particular area of that GeoTIFF. So we're going to open our transformer here. We're going to select our color. Let's choose lime green, and we'll leave the buffer size and the other one as default. And then we'll run this. We'll set our parameters, and you will see here it selected a particular area that we want to focus on, and then the rest is that lime green color, which is really awesome. So you can see there, it's only focusing on that part of that neighborhood. But we're going to move on to the next section here, which I will pass on to Kaylin for common imagery tasks in FME. So take it away, Kaylin.
Thanks, Ellie. So we just reviewed some super cool new imagery tools, but now we're going to show you a couple demos on how you might build out your own custom imagery solutions. So in this section, we're going to get familiar with a scenario, and then we're going to start to build that scenario out. So let's get familiar with our scenario. So your organization's marketing team is preparing for an upcoming user conference. They've requested help from your department preparing photos for an online web portal they're curating. This is where attendees will go to access their agenda, join sessions, and find information about the event. Marketing has provided this project with 4 criteria, so let's go through those. So web images need to be watermarked with the company logo. You can see we're staying on theme here. Watermarks need to be black and white as well as transparent, and web images need to be a minimum width of 800 pixels. And although it's not listed here, we really should be delivering the images back to the marketing team in a web-friendly format. So we have about 1 demo per marketing criteria we're going to meet. And we can get started by kind of getting familiar with our data. So this is what we're working with on the left, and this is the output we're working towards on the right. So before doing anything else, we need to prepare the logo for overlaying. So first we need to convert the logo to black and white, and sometimes this is called grayscale. We're going to use the raster expression evaluator in one raster mode where A represents our raster and the following digit corresponds to a band. So in this case, when you see A and then bracket 0, that's actually regarding our red band. In our band expression or formula, we need to multiply each color channel or band by a weighted sum. The weighted sum will control grayscale intensity, and we're going to see how this works in the following demonstration. Now we'll jump into the demo video. Let's start building the scenario. This scenario will be conducted in 2 steps. Firstly, we'll prepare the watermark, and then we will combine the watermark with the images provided from marketing. To begin our analysis, let's go ahead and bring in our source data set. Our logo is in the PNG format. I'm going to make sure I'm in something called feature caching mode, and I'm going to do a partial run. The log file will tell me our file is read successfully, and now we can see our logo in the graphics window. By clicking around on our image, we can quickly confirm how many bands are in this image. So we have a red, green, blue, and alpha band. Now that our data is in FME, let's start meeting marketing requirements. The first thing we're going to want to do is convert to black and white. We can type and add a raster expression evaluator using our quick add menu. The raster expression evaluator will manipulate raster images. In this case, we're going to want to use it to coarse to gray 8. And then we're going to want to supply an expression. This expression should be used to convert our image to black and white or grayscale. To convert an image to grayscale, we need to multiply each color channel by their weighted sum, and this will control grayscale intensity. By changing these values, you will change the grayscale intensity that you see in the output image. So by using more average values, you're going to see a more muted output with very little contrast. Whereas if we're doing something like this, we'll see a little bit more drastic results. Our logo is fairly simple, so I don't expect results to change too much depending on the formula you use. Then lastly, before moving on, we're going to want to preserve our alpha band or our 4th band. We're going to click OK, and we can do another partial run to see how our image has changed. You'll notice that now the image is in black and white, and we actually only have 2 bands. So we have our grayscale band here, and then we also have our alpha band, which we preserved. We will need to use our alpha band in the next step. So now that the image is in grayscale, we can apply transparency. But to understand transparency, we have to be familiar with the concept of an alpha band. So what is an alpha band? An image is usually made up of colors like red, green, and blue, and sometimes there's an extra layer called the alpha band. And this alpha band is what controls transparency. Each pixel in the alpha band will either have a range value of 0, meaning fully transparent or invisible, or 255, meaning fully opaque, which means completely visible. Any value in between 0 and 255 will carry some form of semi-transparency. It is worth noting a lot of raster transformers will also offer parameters to control transparency, so this is not the only way to do this. Let's take a look at how it's done. Now that our logo is in grayscale, we need to apply some form of transparency. We can notice that our alpha band right now is 255. This means that our logo is not transparent whatsoever. We will need to use an FME tool to reduce that alpha band value to apply transparency. Though there are multiple tools that can be used to do this, we're going to use another raster expression evaluator. Type on the FME canvas to add your raster expression evaluator. Connect it to your data flow and open parameters. The first thing we're going to want to do is preserve our gray 8 band. So we're going to preserve our first band. And then we're also going to want to preserve our alpha band. However, we're going to want to subtract about 100 from it. This will reduce the alpha value from 255 to 155, applying about half full transparency. If we click Run, we can take a look at how transparent our logos become. We can see the colors are more muted, and we can now see that our alpha band has a value of 155, meaning it is partially transparent. Now that our image has been prepared, we can write it out so it can be used in step 2. I'm going to use a feature writer to write out our data. I will explain why during part 2. So we can go ahead and add our feature writer. We'll connect our data. We'll confirm we have the output paths set. And we will click OK. Lastly, we can run our data to export our file. We can see we've got a successful translation and our data set has been written. So just going to note that we actually could have done that black and white and transparency step in a single transformer. So we could have actually put both equations or formulas in a single raster expression evaluator. Okay, moving on. So now we need to combine the image and the logo. So now that our logo is fully prepared, we need to overlay it on the background or web images. So first we need to create placeholders for logo locations, meaning we need to create a point in each location where we want the logo overlaid. There are lots of ways that this can be done. We're going to demonstrate the 2D grid accumulator, but you could have also used a combination of the tiler and center point replacer. Once we've created our insertion points, we're going to use a Mapnik rasterizer to replace each point with a logo. The Mapnik rasterizer gives you fine control over symbolization and labeling using the Mapnik toolkit, so it's really an asset here. Alternatively, from using Mapnik, you could have cloned the image, extracted the point coordinates, and then offset each logo to their respective XY. So let's take a look at how this is done in FME. Step 1 is now complete. We have prepared the watermark to be overlaid. Now we can begin on step 2. In step 2, we will overlay the prepared watermark with our other images. So we can start by taking a look at what marketing's provided us. They've shared 2 JPEG files that they would like watermarked. We can drag and drop our data onto our canvas and leave all parameters as default. We will be reading as a single merge feature type. We click OK to add our reader feature type to the canvas. We can move it to the correct location. And before caching my reader, I'm actually going to begin to build out the rest of the translation. Our first task will be create grid insertion points. This means we need to create a point at each location where we would like the logo overlaid. We can use a grid 2D accumulator to do this. This transformer will create a regular grid of points or rectangular polygons that will span the extent of all input features. Let's add our 2D grid accumulator. We'll connect it to our JPEG. Double-click to set the parameters. Because we're working with two images, we need to enable group by processing, and we need to group by FME base name. This will ensure that the same processes is happening on each image, each image is being handled as a separate feature. We're going to change the grid type to number of cells, and we're going to want to ensure that the grid to create is points centers. We want a total of 9 logos overlaid on our images, so we are going to create a 3x3 grid matrix of points. We're going to click OK. Now we can do the overlay. We'll use a Mapnik rasterizer to do the overlay. We will connect the output port from the 2D grid accumulator, as well as the original image contents. We can double-click to set parameters. We'll need to enable group processing again on FME base name so that this is carried out on both images, and then we can set raster properties. We'll change the resolution to cell spacing and give cell spacing a value of 1. Now properties have been set, we can go ahead and edit our rendering rules. Here's how we control the styling to be done on features. So right now, we need to actually move our rasters up so that they come first, and our grid or image, which I'll show in a second, is actually overlaid on top of the original JPEG. We'll change our symbology to raster and our grid to point. Now we need to edit our point style. Mapnik Rasterizer will allow you to change the symbol type to image. We'll set the image file to our newly created watermark. So you'll notice that we did use a feature writer in part 1, and this parameter does allow you to set an attribute value, meaning that you could actually use a more dynamic approach to this and have FME dataset specified in here, so everything would be handled dynamically. But just to save on transformer count, we're going to hard code this today. The last thing we want to do is, because we don't typically see watermarks perpendicularly, is we're going to want to add a rotation so that our watermark is rotated 45 degrees counterclockwise. We're going to click OK and OK again, and let's take a look at what this produces. So you'll notice that we received 2 output photos with a watermark that is rotated properly and transparent. Awesome. So the last step to satisfy size requirements. We're going to use the raster resampler resize images. We're going to resample to 800 columns, and it's going to reduce the size of this image by about 9 times. We're going to use existing raster properties to proportionally scale or resize along the y-axis or calculate the number of rows. Let's take a look at how the raster resampler changes image size. Now that the watermark is overlaid, we need to prepare the images in the correct size. To do this, we need to change the resolution to have only 800 columns. We can do this by using a raster resampler. To change an image size in FME, you need to touch or change the resolution. Because we only have 800 columns specified for a resolution, we need to proportionally create the number of rows. And we can do this by using existing raster properties. We're going to type and add a raster property extractor. This is going to extract properties like how many bands, how many columns, and how many rows are in the raster. There are no parameters to set for this transformer, so we can go ahead and run it. Now we can resample or resize. We're going to add a resampler. We're going to connect it to the output port of our raster property extractor. And we're going to specify the number of rows to be 800. Now we've satisfied marketing requirements, but we also need to calculate the correct number of rows. To do this, we'll use an equation.
Let's open the arithmetic editor. I'm going to paste in an expression that will proportionally create the correct number of rows and then round that number to a whole number. And that's because we can't have a decimal number of rows in our output raster. We're going to click OK and OK again. And now we're ready to write. We're going to write to Google WebP because it transmits well over the internet. Let's go ahead and add our writer. We're going to search Google WebP and we'll select our output dataset. We'll store them in the same folder as our marketing images. And we'll leave the raster file definition as automatic. The only thing we're going to want to do is add a suffix saying watermarked. That way we know this image has the watermark overlaid on it. We're going to click OK, connect our data, and then we can run our workspace to write or export the photos. Let's take a look at our output. We can see we have 2 new WebP photos.
All right, so I actually didn't prove the resolution at the end of the video there. However, if you were to run this workspace, navigate through the feature information window down to raster properties and find the resolution parameter, you would see about 533 rows produced for those 800 columns. So taking a look at the scenario on a whole, we've successfully delivered the images back to our marketing team in the Google WebP format. So why Google WebP? Google WebP has a great reputation for supporting high compression while maintaining high image quality. Not to mention it's compatible with most modern web standards, meaning it's really, really easy for people to work with if they're using various browsers. So our scenario has concluded, but instead of having your marketing team approach you every event season, you could consider using the FME platform to create a self-serve flow app or automation where the marketing team can upload and watermark their own images using an online self-serve tool. Awesome. And now Donald's going to run us through advanced imagery.
Yeah, thanks, Kaylin. That scenario really highlights the real-world applications of working with imagery data within FME. So great job. So our last section is advanced imagery. So I'm going to briefly show everyone the amazing capabilities of working with imagery in FME and the endless possibilities. I'd like to quickly give a shout out to Dimitri for the amazing support and providing many of the outputs for this section. So our first slide shows this amazing imagery tool. This is a farmland monitoring tool which calculates NDVI, which is the normalized difference vegetation index. With this tool, we're able to compare 2 images in their own format. So for example, RGB, IR, which is infrared, and NDVI. I'll just give a quick explanation of infrared and NDVI. So infrared is a type of light that is invisible to the human eye, but can be detected by specialized sensors. It's often used in farming for detecting crop health and forestry for detecting areas of deforestation. NDVI, it is a simple way to measure the health and density of vegetation using satellite or aerial imagery. This is a great tool that can highlight just how healthy a farmer's crops may be when selecting the NDVI option, or it's a great way to detect deforestation when selecting the infrared option. This tool will be shared for everyone watching, so be sure to play around with it and use it for yourself. Draping is also a very useful tool. So this means placing a flat 2D image, like a map, aerial photo, or satellite image, over a 3D surface, for example, a terrain model. As you can see from our slide, the city of Vancouver is represented while also having a 3D visualization of the local mountain ranges. This can be incredibly useful when dealing with terrain models and city models. For really advanced uses, it can even be used in virtual tours for tourism. Reclassify numeric rasters. So imagery classification using numeric rasters means updating or changing the values in a grid-like image made of numbers to group or simplify the information. So imagine a map where each square or pixel has a number representing something like land type. 1 equals forest and 2 equals water. Reclassification changes these numbers, like grouping all water types into one number, making it easier to analyze and understand the data. Examples of this can include land cover data and slope data. Lastly, but certainly not least, is how FME can integrate with other platforms and implement deep learning models. These are computer models that are designed to learn patterns and features from images. These models use a type of artificial intelligence. For example, it can look at pictures and learn to recognize objects like cats or cars by analyzing features like edges, shapes, and colors. As you see in our slide, using Pictera, we are able to identify points of interest. In this case, we wanted to identify sea lions on a beach. It could also be used to identify cracks on roads or pavements, as seen in our second picture. The possibilities are almost endless with deep learning models. Using the recognition connector, this allows us to access the Amazon Rekognition Service AI computer vision service. In the examples on the slides, we're able to detect emotions. As you can see from my face, it was able to detect happy emotions, surprise emotions, sad emotions, and angry emotions. Construction or medical companies can implement this technology too using a PPE check. This helps check to see if people are wearing their personal protective equipment. The possibilities are really endless. This wraps up the advanced imagery section. I'll hand it back to Ali, who will wrap it up with the conclusion.
Thanks, Donald. Yeah, that was a really great overview of the advanced imagery that Dimitri has done with some of them. And then my favorite from that part was calculate NDVI and compare imagery, and the recognition one. Love that, Donald. To summarize, this is, as we've explained to you and showed some demos to you, you can turn your imagery into notable outcomes for your FME workflows. And we've showcased different use cases, resources, and custom transformers that you can check out and try for yourself and build your own workflows from them. And then, yeah, the advanced use cases that Donald put perfectly. And yeah, we've been doing this for over 30 plus years of solving data challenges, over 37,000 members on the community, over 25,000 organizations, and 140 global partners that we have in 128 countries. So thank you all, and we've been pretty established with what we support here. And yeah, we've started focused on GIS towards the beginning here. With less than 10 formats back in 1995, but over the years we listened to our customers, what they basically needed, and now we support more than 500 different formats, and you can see just some of them there, which is really, really amazing. And I will pass it over to Elizabeth for other resources.
Amazing. Thank you, Ali. Okay, so just to wrap us up here, we're all about free resources here at SAFE. You can get free instructor-led training over at our academy. And I'll also highlight our webinars. We've got lots of upcoming ones. Our podcast program, if you're looking for some more audio-based learning, we also have a handful available over at EM360. And in terms of next steps, we'd love to help you get started with anything that you may be needing a hand with when it comes to your data challenges. So I'll go ahead and promote a link for that too. If you'd like to email us direct, you can just click that handy button there. And our FME Accelerator course, it is 90 minutes free of charge, and it's quite helpful as a basis for getting started with FME. Claim your community badge. So if you're a member of our FME community, we have a badge code for you to redeem today. I will drop that in the chat here. And if you aren't yet a member, please do check it out. It's a great place. You can network with other users and experts alike, and yeah, gain solutions to your challenges there.
Awesome. Thank you, Elizabeth. Hi, everyone. My name is Moyen, and I'll be taking us through our live Q&A today. So if I can just ask our presenters to join me on stage now, and yeah, we'll take a look at some of the questions that have come in throughout the webinar today.
Hey.
Hi, everyone. Yeah, it seems that we have quite a few questions coming in, so I can promote them above the stage now. We can start a live answer. So it seems we have a question from Lauren.
Yeah, so we didn't actually discuss it earlier on in the webinar, but FME does support reading and writing Esri Mosaic datasets, and that's usually done through the Esri geodatabase reader and writer. You can work with Mosaic databases and configure Mosaic parameters, such as ordering and raster types, but we didn't really touch on it within this webinar.
Yeah, no worries. And then it seems we also have another question coming in.
That question we can follow up with unless Dimitri has something to add. He can
Okay.
the answer there, but we can follow up.
Sounds good. Yeah, I think Dimitri is active in the questions tab, so maybe he can respond to this question. We have this one as well.
I wouldn't know totally offhand, but I believe their recognition connector that does have the capabilities, recommended approaches for OCR and FME, but I'm sure Dimitri can probably further discuss it.
Well, we have a few custom transformers, not custom transformers, standard transformers that can detect texts. Basically, all vision connectors, Azure, Google, and recognition, they all will read text with different with different level of success. Some are better, some are worse. OCR with AI, honestly, I think it will be gone soon. We had a Tesseract connector, which I created like maybe 10 years ago, which are pure OCR with no AI, and it's not that good. So for this purpose, you would better use something like Google Vision or other AI from big vendors.
Awesome. Thank you, Dimitri. Did you also have an answer for Joanna? She was just asking if we have any recommendations for cleaning up the staircase effect, then vectorizing raster data.
So so if you use just FME, there's nothing else, then it's generalizer. It has lots of options to smooth, densify, and just go into that transformer. It has like 10 different algorithms that will allow you to smooth your raster. I also published, again, like years and years ago, a portrait scholar, which calls a command line utility that vectorizes things. And you can try that one. It creates you smooth lines right away. So also a possibility.
Awesome. Yeah. And we also have another question that came in from Mike. Oh, I think Donald, you've responded. So that's great.
Yeah, I know we have available the web map service readers and writers and the web map tile service reader and writers. So, and then you can kind of just use the standard transformers within FME.
We also have this question that just came in as well.
So we support writing GLTF files. I think, yeah, just set it on both sides. And if GLTF supports it, then we should be able to support it. But it's not a raster question.
That's good. Perfect. Yeah, I'm just taking a scan to see if we've missed any questions. Yeah, in the meantime, do we have anything else that we want to highlight for the attendees today as well regarding the webinar?
I just want to remind everybody in about 2-3 weeks, I can't remember the exact date, we do have a webinar, a further webinar on imagery. So be sure to check that out and tune in.
Perfect. Thank you, Donald. Yeah, and yeah, I think we had a question in the chat about the recording. So after, yeah, we wrap up the session, the recording will be emailed to all attendees along with the slides will also be available for download. Yeah, so you will get the recording.
Maybe I can answer this one about identifying things on satellite images. So ideally, of course, it is better to use specialized tools like Pictera, where you would train and you show yourself on your own data where your objects are, and the training set shouldn't be too big. You can have like 30 objects to train on. You would show your objects, then you would show where you don't have your objects, run training, and then it works really, really well. In general, among general LLMs, you can try the best to work with spatial, not just in geographic sense, but in general, hiding some dimension things. The best engine is Gemini. Gemini not only detects things, tells you that you have a cat on this image. It also will tell the bounding box where exactly it is. It also even create masks that will outline the thing that it found. So like really, really great engine to work with. So Gemini, have a look at Gemini, not at, Olama, the local LLMs. They're not that good yet.
Awesome. Yeah, I think Evie just shared the next imagery webinar. So if anyone is interested to dive deeper into the topic, please, sign up for that webinar happening. Yeah, I don't think we have any new questions rolling in at this time. So I can definitely start closing out the webinar. And if anyone has any last minute questions, please drop those in the questions tab. We will leave the webinar running for another 5 minutes. So you can save out any links that we've sent out or ask any last questions. And if we didn't get to your question, we will be sure to follow up with you after the webinar. I just want to ask everyone for a moment to fill out our webinar survey as well. We appreciate any feedback on these. And thank you so much for attending, everyone.
See you guys. Bye.
Thank you. Bye.